factor trinomials. After watching this video, I will be able to factor a quadratic expression that has a leading coefficient. Okay, so I want to factor this type of quadratic expression, and I am going to do the same thing I was previously doing. I am going to multiply my first term, coefficient, the leading coefficient, times my c, my last term, my constant. And the only reason this is different is because now my leading coefficient is not just 1, but it is a number. So 2 times 36, that gives me 72. So I want to find numbers that multiply together to give me 72 and add up together to give me 22, my middle term. So I'm going to list factors of 72. That'd be 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12. And I'm going to stop there because I realize that 4 and 18 might work. So I'm going to write 4 and 18 and see if they both could be positive. So 4 times 18, when they're both positive, gives me a positive 72. And then 4 plus 18 gives me 22. So it checks out for both. So I will rewrite my expression, 2n squared. The 22n now becomes 4n and 18n. And then 36 days. And now I'll factor by grouping. So I group my first two terms, and I factor out a 2n. So I'm left with n plus 2. Then I group my last two terms, and I'm going to factor out an 18, and I'm left with n plus 2. And that's great because now I have my common factor, which is what I wanted, n plus 2. And then what's left over, 2n plus 18. And these would be my two factors. So now you try. Okay, so I am going to do my A times my C. So 2 times 180, that's going to give me 360. Now, when you have a very large number, it might be very hard to find factors of 360, or it might be more time consuming. So it might be useful to do a greatest common factor of my polynomial. Is there a number that I can divide 2, 38, and 180 by? Yes, I can divide it by 2. So I am going to factor out a number 2 from my original using my GCF. So my GCF is 2, and now I'm left over with x squared. 38 divided by 2 is equal to 19. 180 divided by 2 is equal to 90. So now my numbers are a little smaller, and now I am going to factor this inside polynomial. So 1 times 90 is equal to 90. And I'm going to list factors of 90 that add up to give me 19. So 2 and 45 work. 3 and 30 work. 90 divided by 4, does it work? No, because I get a decimal. 90 divided by 5 works. So 5 and 18. 90 divided by 6 works because I get 15. 90 divided by 7 does not work. By 9, it works, and I see that that gives me 19. So 9 times 10 gives me 90. 9 plus 10 gives me 19. So that means I am going to rewrite my top polynomial, and I'm going to remember to keep that 2 down, that I'm not doing anything with it, just because I might forget all about it. So I am left with x squared. Now this 19 becomes 9x and 10x. So now I can factor by grouping. So I'm going to take out a common x, and I am left with x plus 9. I'm going to take out a 10. I am left with x plus 9. So what is left over? Well, the 2 is left over from up here. I'm just going to bring it down. And then I have a common x plus 9. And then I have x and a positive 10. So my correct answer would be A.